कर दिए। कर दिए। कर दिए। यहाँ से हटा दो यूट्यूब। बस वो जूम वाला रखो। रखो, हटा ही दो पूरा। Let's continue from the last lecture. We have covered zero order, first order, second order, and nth order reactions till now, and we are continuing from there. Am I audible? Am I audible? Okay, let's continue. We are doing some easy steps like experimental mental determination of order of reactions. Determination of order of reaction. Important but easy. Experimental determination of order of reactions. First method is initial rate method. Initial rate method. In this section, you will be given some data, and from that data, you have to predict the order of reaction. By the use of data, you have to apply some mind, and then you have to predict the order of reaction. Data will be given, and by using that data, you have to predict the order of reaction. Now, initial rate method, how question will be given, what kind of data will be given. See, if rate equals to k into, let's say, a ki power p and b raised to power q. So order will be p plus q. Order will be p plus q. Data given is concentration of A, concentration of B, and that rate. Why initial rate? Name is suggesting initial rate. Why initial rate? Because these concentration are given at t equals to 0. These concentration are at t equals to 0. So rate will be also at t equals to 0, and that t equals to 0 rate is known as initial rate. Let's say I'm giving some data 0.2, let's say 0.01, 0.4, let's say this one is 0.01 only. If this is 0.2 and this is 0.02, and I'm giving some data of rate, let's say 2 into 10 to the minus 4. This thing is, let's say 8 into 10 to the minus 4, and this thing is, let's say 4 into 10 to the minus 4. With the help of these data, can you predict the order of reaction just by yourself? Can you predict the order of reaction? You have to predict P value and then Q value, then add these two values. Hurry up. I'm following your chat. Very good evening. Very good evening. Now give answers. P is 2, Q is 1. P is 2, Q is 1. I think we have the answer. Yes, P is equals to 2 and Q is equals to 1. How many of you have got right? P2, Q1. One, two, three. Only three, four people. Okay. Let's see what's happening here. It's very simple method. When you are looking at A, ki how A is varying with the concentration of A varies with the rate, or you can say ki how concentration of A is affecting the rate. That time you see the data where concentration of B is same. This is a common sense. If you are seeing the effect of concentration of A when A is varying, that time you have to see in that way that concentration of B is constant. Just look at those data only. So you have to look at first and second data. Here A is getting 2 times, or A raised to power is P. A raised to power is P. A is getting 2 times and A raised to power is P. And from first and second data we can say that this is getting 4 times. 4 times matlab 2 raised to power 2. So if we are equating these two, so 2 raised to power 2 equals to 2 raised to power 2, where P equals to 2. And in that same fashion, you can calculate B raised to power what? B raised to power Q. While solving for B, look at the data where concentration of A is same. Look at the data where concentration of A is same. So what data have concentration of A same? First and third data. See, first and third data have same concentration of A. From first to third, see, concentration of A is getting 2 times 2 raised to power Q. And from first to third, see, this is getting 2 times for the 2 raised to power 1. So Q equals to 1. It is very simple thing. You can predict the order of reaction with the given set of data. What things will be given? Concentrations and rate. It's very easy method to predict the order of reaction. Second method is T half method. As you know, for nth order reaction, T half is directly proportional to 1 upon A naught raised to power n minus 1. T half is inversely proportional to A naught raised to power n minus 1. You can write this thing as A naught raised to power 1 minus n. A naught raised to power 1 minus n. We have done this in last lecture. Now, I'm giving one question and try to solve it. Let's see A naught, and this is T half. 0.5 molar. Let's say this is 2 molar. This is 10 minutes and this is 160 minutes. Find order of reaction. Find order of reaction. For these set of data, find order of reaction. Hurry up. Just for apply these things. Just apply these things. Answers, answers, answers. Ishan, your answer is incorrect. Your answer is incorrect. YouTube people, 1 minus n is 2. Then n key value is, what is the value of n then? YouTube, if anyone is watching on YouTube, I'm following your chat also. No, this is not a second order reaction. You can see from here. Second order reaction. You can see from here. Second order reaction. You can see from here. Second order Here it is 4 times. So 4 raised to power 1 minus n. This same thing. The same power. Like we did in the last question. This. And this is 16 times. 16 times means 4 raised to power 2. So you will have to equate 1 minus n equals to 2. So n equals to minus 1. N can be negative. Order can be positive, negative, 0, fractional, integer, non-integer. N can be anything. So n is equals to minus 1. Don't get confused by getting n equals to minus 1. N can be minus 1. So this was simple method when you were relating T half with A naught, and it is inversely proportional to A naught raised to power n minus 1. Third method is unit of K method. Unit of K method. As I have said in the last lectures, unit of K is very important. Unit of K is very important. Particular unit of K. In fact, when value of K is given, then magnitude is not that much important as the unit of K is important. Because unit of K gives direct hint towards the order of reaction. Let's do one question here. If for this reaction A raised to power A converting into product, let's say it's K equals to 4 into 10 to minus 3 m square R inverse. Then A naught, this is T half, 1 molar, this is 2 molar. Let's say this is 10 minutes and this is 80 minutes. Sorry. You have to find this value T half. If concentration is increased 2 times, then what will be the T half value now? Your given data is this only. From this, you have to predict this T half value. Do it. Do it, do it, do it, do it. Fast. Hurry up. डेविल लिख रहा है पहले जो लेक्चर लेते थे वो सर कहाँ है? मतलब कोई तो दूसरा इंसान लग रहा है क्या यहाँ पे? डेविल आई एम द सेम. Yes, answer, answer, answer. Now you know the nth order reactions unit of K. in general unit of K, which is moles per liter raised to power 1 minus n time inverse. So you just can compare this 2 with 1 minus n. Compare this 2 with 1 minus n. Compare this 2 with 1 minus n. So you have 1 minus n equals to 2. Now you know that T half is directly proportional to A naught raised to power 1 minus n. A naught raised to power 1 minus n. You have done this twice. So this will be 2 raised to power 2 times. That means 4 times. 4 times means 10 into 4 means 40 minutes. It is that simple. Vedika 20 minutes nahi, 40 minutes. 1 minus n's value is 2. So just put this thing here. Means T half is directly proportional to A naught raised to power 2. If A naught is getting twice, then T half will get 4 times because 2 raised to power 2. Last iska question, fourth method is graphical method. Just try ki each and everyone is doing this question correctly. Nth order, we have done nth order ka graph. In the last lecture, we have done nth order's graph. I'm giving question directly. At raised to power minus 4 versus t, and this graph is something like this. This is given if t3 by 4 is 51 minutes. If t3 by 4 is 51 minutes, then t half will be. T half will be. I'm giving you options as well. Let's say 10 minutes, 3 minutes, 4 minutes, cannot be determined. From this graph, you have to predict the order of reaction. Some hint is given. Look at this graph closely. Look at this graph closely. You will get some hint. Order of reaction is hidden in somewhere. कहीं ना कहीं तो छिपा है. जैसे दुल्हन के हाथ में, मेहंदी वाले हाथ में दूल्हे का कुछ नाम छुपा होता है, वैसे इस ग्राफ में कहीं ऑर्डर छुपा हुआ है. ढूंढ लो. Answers, answers, answers. C or D? How it can be both? How it can be both C and D? If C is there, then D cannot be. If D is there, then C cannot be. ऐसे तुक्के मार रहे हो कि आ भी रहा है? Let me tell you, correct answer is 3 minutes. How many of you are getting this answer? Raise your hand proudly. Anyone? Dubeji is getting the correct answer. Anyone else? Dubeji, you are getting or not? Okay. Good, good, good. See, in nth order reactions graph, this y-axis represents 1 upon at raised to power n minus 1. This y-intercept represents 1 upon at raised to power n minus 1, and this slope is represented by n minus 1 times k. 1 upon at raised to power n minus 1. This y-intercept is 1 upon a naught raised to power n minus 1, and this slope is n minus 1k. Keep in mind, these three data can give you hint about order of reaction. In this question, we have given this data. Now you can write this as well as at raised to power 1 minus n, and this 1 minus is n upon, no, 1 minus n is given as minus 4. So n is equals to 5. N is equals to 5, or you can say n minus 1 is 4, whatever you want to say. Why I'm taking n minus 1? Because T3 by 4 is equals to 2 raised to power n minus 1 plus 1 times T half. This is very important relationship for nth order reaction. We have done this in the last lecture. T3 by 4 equals to 2 raised to power n minus 1 plus 1 times T half. Okay, now if you know this thing, and you know n minus 1 value as well, now calculate. अरे ये भी पता है, ये भी पता है, अभी तो बता दो कि you are getting 3 minutes or not. T3 by 4 is equals to 2 raised to power 4 plus 1 times T half. T half, yes, this is 51 minutes. This is 17 into T half. So T half is 3 minutes. See, from graph, we have done 3 half and T3 by 4 relation type question. So these are the tricks, kind of common sense tricks, which will help you in predicting the order of reaction. These were the kind of 4 methods to predict the order of reactions. Then, next thing we are doing, this is JEE's favorite, or kind of asked in NEET as well, but JEE's favorite questions. In this section, we are doing experimental determination of rate constant of first order reactions. Only first order reactions, not first, zero, second, nth order. Only first order reactions using various informations. Keep this thing in mind. We are covering here only first order reactions, or in that also we are finding rate constant of the reaction, rate constant of first order reaction. Sir, what are you doing? We know this thing as well. Kt equals to ln a naught upon at. Why are you doing a full heading and then telling us? Because these at and a naught will not be given directly. At and a naught won't be given directly. Some other information will be given, and we have to relate those information with these two data. You won't be given a naught and at directly. Otherwise, this question will be so simple. A naught and at won't be given. Some other informations will be given, and we have to relate those information with a naught and at and find k. So k equals to 1 upon t ln a naught upon AT, and we know this thing is equals to ln A upon A minus X. In some way, we have to relate those given information with A and A minus X, and we have to find the answer. Say, the first information or first type of question we are doing, if pressure related informations are given. If pressure related, and this part is very important from the JE point of view. If pressure and your exam, board exam as well, if pressure related information is given, related information is given. Let me take one example, A converting into B plus C. Now some starting points, you have to keep these things in mind very well. Like A, B and C, you have to look carefully in what state these substances are given. In what phase these are given, solid, liquid or gaseous. You know from chemical equilibrium or gaseous state as well. Okay, gaseous state is not in the NCERT. Gaseous state means states of matter. I think that kind of chapter was there in NCERT. Now with the NCERT's rationalization, that chapter has been removed from the NCERT. So no states of matter type chapter. But you have done this thing in chemical equilibrium, that we are taking not for NEET as well. Gaseous state is not for NEET. States of matter, दुबे जी states of matter कोई चैप्टर पढ़ाया था क्या? No ना. So what important thing is there? A converting into B plus C, you have to take care that A and B and C are gaseous substances or in some other states like solid or liquid. If they are in solid and liquid, then we won't consider or we won't assume their pressures. We assume their pressures negligible with respect to gaseous substances. I'm saying again, you don't have to consider the pressure of solids and liquids because we consider their pressure negligible with respect to gaseous substances. I'm saying again, you don't have to consider pressure of solids and liquids. You have done this thing in chemical equilibrium as well. So, first thing you have to keep in mind that these substances are in which state. If they are in gaseous state, then you will consider their pressure. If they are in solid or liquid, then you won't. And what else they can do? They can put some stoichiometric coefficients. We will take care of that. They can do two things. Instead of gaseous, they can put some solid or liquid, then you won't consider its pressure. And they can put some stoichiometric coefficient. Right now I have taken very simple reaction, 1 1 1 stoichiometric coefficient. They can put some stoichiometric coefficient as well. You will have to take care of that as well. Now at t equals to 0, its pressure is, let's say, Pa naught. This is 0, this is 0. At given time t, this is Pa naught minus x. A's pressure is Pa naught minus x at given time t. So its pressure will be x and its pressure will be x. If 2 was in front of this B or 2 was the stoichiometric coefficient of B, then here it will be 2x. If C is, let's say, solid or liquid, then we won't write anything for C. Are you getting my point? If I have done two variations, if I'm putting some stoichiometric coefficient, then we can take care of it. If I'm changing the state like solid and liquid, then we won't write anything for that substance. Then t equals to infinite. This is 0, this is Pa naught, and this is Pa naught as well. Now, you would be given three types of data, P naught, Pt, and P infinite. Third most important thing, I think the most important thing for this topic, this P naught, Pt, and P infinite does not represent individual pressures. P naught, Pt, and P infinite these data don't represent the individual pressures. Then what does it represent? Then it represents the total pressure of the container. This is not the pressure of individual substance, let's say A, B, and C at t equals to 0 and given time t and t equals to infinite. Why t equals to infinite? Because these reactions are first order reaction. Look at the heading. Every reaction covered here will be first order reaction. So completion time is infinite. Now, these three data represents total pressure of the container. ये दिमाग में अच्छे से डाल दो बात. Total pressure of container. Total pressure of container. Now, I'm equating these P naught, PT, P infinite with these data. एक बार ये दिमाग में अच्छे से values रख लो. I'm going on to the next page. P naught, that means pressure at T equals to 0. T equals to 0, in the container only A was present. So A's pressure was PA naught. B का pressure and C का pressure was 0. Then PT equals to PA naught minus X plus this was the pressure of A. Then pressure of B was X, and then pressure of C was also X. Then it is equals to PA naught plus X. This was PT. Now P infinite. A ka pressure was 0. Then PA naught plus PA naught. It's 2PN. So in conclusion, P naught equals to PA naught. PT equals to PA naught plus X, and P infinite equals to 2PA naught. These are not the fixed formulas. I'm saying these are not the fixed formulas. It would vary with the given reaction. If stoichiometric options are changed, then these will vary. If I have changed the state of some substance, then it can vary. So look at the concept, how I'm writing. Don't focus on the key, remembering the formulas. Now, if inert gas is also present in the container, if inert gas is also present in the container, then we have to consider that pressure as well, because P naught, PT and P infinite represents not only A, B, C ka pressure, it represents total pressure of the container. Means if inert gas is there, then I have to consider that pressure as well in total pressures of the container. So let's say if inert gas is present, then we have to add inert gas pressure as well. Because it is present in the container, then we have to consider in the total pressure of the container. Why I am writing at each and every place, each and every time? Because inert gas is not reacting with each and everyone, anyone. Each and everyone to chodo. It is not reacting with anyone. That's why it is inert. Inert gas is not reacting with any substance A, B or C. Its pressure is constant throughout the time. So we are adding at each and every point of time P inert, P inert, P inert. How to solve the question? What we have to deal with? K, we have to find rate constant of first order reaction. So 1 upon T ln A naught upon AT. In place of A naught and AT, we have pressures values. How to relate A naught and AT with pressures? So we know कि PV equals to nRT, P equals to N by V times RT. N by V is nothing but concentration only. So we know कि P is directly proportional to concentration. Pressure is directly proportional to concentration. N by V is concentration. So in place of concentration, I can write pressure as well. In place of concentration, I can write pressure. So K equals to 1 upon T ln. But pressure of what? Here concentration of A, so pressure of A. Concentration of A at T equals to 0, concentration of A at given time T. So I have to write pressure of A at T equals to 0 and pressure of A at given time T. Come here, pressure of A at T equals to 0 is PA naught and pressure of A at given time T is PA naught minus X. Because I'm replacing concentration with pressure, but concentration of what? Concentration of A. Concentration of A in place of that pressure of A. So pressure of A at T equals to 0 is PA naught and pressure of A at given time T is PA naught minus X. So PA naught, this is pressure of A at T equals to 0 and PA naught minus X, this is pressure of A at given time T. I have to find these two values, PA naught and X. If I have these two values, then I will get the answer. I will summarize again. These three datas are not pressure of A. These three data are total pressure of the container. Here they can do the two type of variations, stoichiometric coefficient variation and state change, solid, liquid, gas. You have to consider pressure only when it is gaseous substance, not for solids and liquids. Next thing, you have to write these things. Then you have to find PA naught and X. How? We will do one question and then learn from there. Let's do one question. And one more extra information. If only two data are given, which two data? Among these three, only two data are given and P inert is not given. Listen carefully. Among these three, along with PT, P naught or P infinite, P naught and P infinite, P naught or P infinite is given. Means two data are given, PT, and among P naught and P infinite only one data is given. PT, and among P naught and P infinite only one data is given and P inert is not given, then you will assume P inert as 0. You will assume P inert as 0. दिमाग में डाल दो ये बात अच्छे से. मैं वापस हिंदी में बोल रहा हूं. पीटी के साथ साथ इन दोनों में से कोई एक वैल्यू दी हुई है. पीटी के साथ साथ इन दोनों में से कोई एक वैल्यू दे रखी है और इनर्ट गैस का प्रेशर नहीं दे रखा है. इनर्ट गैस का प्रेशर नहीं दे रखा है. उस टाइम पे आप इनर्ट गैस के प्रेशर को कितना लोगे? 0 लोगे. इन रेस्ट ऑफ द केसेस, rest of the cases means rest of the all the cases means what kind of questions can be asked? These two datas, among these three two datas, and P inert is given, P inert ka value is given, then you will have to consider the P inert. And if all the three datas are given, that time also you have to take P inert. If P inert is there, then some value will come, otherwise its value will be 0. You have to consider P inert as 0 only when two datas are given. One data is PT and among these two only one data is given. That time you will assume P inert as 0. Now keep these things in mind while doing the question. I'm giving you one question. ये करके अच्छा लगेगा आपको. If A gaseous is converting into 2B gaseous plus C gaseous, it is given that this reaction is first order reaction. This reaction is first order reaction. Now, extra information is total pressure at T equals to 2.303 seconds is, let's say, 450 mm of Hg, and after sufficient time, this data is given as Okay, no. Change this data. 300 mm of Hg, and this is 450 mm of Hg. After sufficient time means after completion time. After sufficient time means after completion time. Completion time means which data? P naught or P infinite? It is P infinite, and this is PT. See, only two data, that means P inert, you have to take 0. Then find what? First, K, and second, T3 by 4. Question is in front of you. Come on, do it. You will feel good after doing this question. Do it. करके दिखा दो. एक डॉट करके बोल रहा है, व्हाई आर यू स्पीकिंग इन इंग्लिश टुडे? आई फाइंड इट बेटर व्हेन आई हियर हिंदी इन योर वॉइस. तो डॉट महोदय, क्योंकि कुछ बच्चे इंग्लिश समझने वाले ही है, सिर्फ इंग्लिश ही समझ में आती है उनको, हिंदी समझ ही नहीं आती. दे कांट अंडरस्टैंड इन हिंदी, सो आई हैव टू स्पीक इन इंग्लिश एज वेल. यू कैन अंडरस्टैंड इन इंग्लिश, सो थोड़ा खुददार दिल बनो, दूसरों को भी समझ में आए वैसे काम करो. अरे तुम तो अंग्रेजी में समझ ही सकते हो. कोई जूम पे है जिसको अंग्रेजी समझ में नहीं आती? एनीवन? इफ एनीवन इज फाइंडिंग डिफिकल्टी इन अंडरस्टैंडिंग इंग्लिश और माय इंग्लिश, so you can tell me, I will translate into my language, means your language, or simple language, or घर की language. क्वेश्चन करके बताओ जल्दी. People on YouTube. Answers. Yes, from YouTube. Are you understanding today? Anyone from YouTube can confirm. Are you understanding it today or not? I'm speaking English only for you, for Karnataka people. Anyone from Karnataka? Type yes or no. Okay. Okay. Good. Now attempt this question and give me answer. Answer. कोई तो दे दो. K equals to log 2 by 3. No, it's wrong answer. I'm waiting for your answers. Okay, do one thing. If you have written this question, then I'm okay. Let me do on the next page. Today I will give you the PDF as well. You can write this thing PA naught 0, 0. This is PA naught minus X. This is this time 2X, not X, because stoichiometric coefficient is changed from 1 to 2. So 2x and then x at t equals to infinite, this is 0, this is 2 PA naught and C is PA naught. Now you have two data at given time t which is 2.303. ईशान बिल्कुल सही आंसर है. ईशान, योर आंसर इज करेक्ट. log 2 इज करेक्ट आंसर. डॉट ने भी सही आंसर दिया है. यस यस. सो pt which is equals to 300 and that is equals to, you have to add pressures of A, B and C at given time t. A, B and C. So addition of these three will be PA naught plus 2x and P infinite is 450 and that is equals to addition of pressures of B and C at t equals to infinite, which will give you 3 PA naught. Now from these two data, why I'm ignoring P naught? Because only two data are given. So now calculate PA naught. PA naught is 150 mm of Hg and put this PA naught here, then you will get X that will be equals to 75 mm of Hg. ये दोनों आ गए हैं. If you are getting these two, then just put into the formula. What is the formula? K equals to 1 upon T. What is the value of T? 2.303. Convert ln into log. So you will get this time का value is good value, not a bad value. Don't make faces. ये अच्छी वैल्यूज है. जो log को ln को log में कन्वर्ट करते टाइम कैंसिल आउट हो जाएगी. इफ यू कन्वर्ट ln into log then you will get 2.303 log PA naught. What is the value of PA naught? 150 upon PA naught minus x. PA naught minus x. This is log 2. Answer is log 2. And if you look carefully, 50% of pressure is reducing. In the similar way, in the same way, you can say कि 50% is reactant is reacting. If 50% is reacting, then 2.303 is T half of this reaction. See, 150, 75, 150, 75, 50% of reactant is reacting. 50% of reactant is reacting. So, T3 by 4. What is the relationship between T3 by 4 and T half in first order reaction? What is the relationship between T3 by 4 and T half in the first order reaction? 2 times T half. You know the T half. So, T3 by 4 is just double of 2.303. I haven't done anything because I know कि 50% is reacting. So this time 2.303 represents T half of this reaction. And I know T3 by 4 is 2 times of T half in first order reaction. So this is 4.606. These are the two answers. Log 2 is 0.3 only. 0.3. Let's do one more question because these kind of questions are asked frequently in the competitive exams. This was the very simple question. Now I'm twisting some things. Try to solve it. How many have got it by yourself? Raise your hand. कितनों का आ गया था? बस only 2-3. अभी कितनों को समझ में आया? अभी कितनों को समझ में आ गया? बताने के बाद में समझ में आ गया. Raise your hand. बताने के बाद समझ में आ गया. Please raise your hand. Okay, only 8. बाकी सो रहे हो क्या? किसी को नहीं समझ में आया देन आस्क इट. किसी को नहीं समझ में आया, कुछ समझाना है. इफ एनीवन इज कंफ्यूज्ड और नॉट गेटिंग, इफ एनीवन हैज एनी डाउट्स देन प्लीज आस्क मी ऑन चैट. आई एम सेइंग इट अगेन. इफ एनीवन इज not understanding this question then ask me on chat. because these questions are very important questions. These questions are asked repeatedly. Okay. One more question for you. 2A gaseous converting into 3B gaseous plus 4C solid. What is given here? PT equals to 350 mm of Hg and P infinite is 450 mm of Hg, and time is, this time is 4.606, let's say seconds. Then find what you have to find: first K and second T half, given that this reaction is first order reaction. Come on, do it. Let's see who is giving answer quickly. करके दिखाओ जरा, ये क्या क्या चेंजेस किए हैं मैंने. स्टैक्योमेट्रिक कोएफिशिएंट्स आर आल्सो चेंज्ड एंड states of matter is also changed from gaseous to solid. C is not gaseous, C is solid. But data, only two data are given. That means you don't have to consider inert gas presence. P inert can be taken as 0. Answer, answer, answer. दे दो भाई आंसर. 2.93 into 10⁻⁻1. नो, डॉट गलत आंसर है, रॉन्ग. नो, मधुर, इट्स रॉन्ग आंसर. मधुर अग्रवाल, रॉन्ग. ओके, let me do it. T equals to 0. This is PA naught. This is 0. I don't have to consider this thing. C, I don't have to consider because C is solid. So I don't have to consider its pressures. Vedika, No, it's wrong. Weboi, wrong. Isan, it's wrong. Anyone else? But Isan, you are nearby, but not exact answer. But you are doing mistakes. Okay, T half is 10 seconds. T half is 10 seconds. I have to check that. What is the value of K? Vedika, what is value of K? Rate constant. Okay, now look on the screen. This is PA naught, this is 0. At given time t, this is PA naught minus x. If this is reacting x, then this will be 3 by 2 times x. 2, then 3, then 1, then 3 by 2, x, then 3 by 2 times x. And t equals to infinite. This is 0, and this is 3 by 2 times PA naught. Now, Vedika, kind of this answer, not exact, but kind of you are correct. Kind of, kind of. Exact answer is 0.0045, not 5. Now, I know that PT is given as 350. PT is sum of these two pressures. So, these two pressures ka sum is x by 2 equals to 350. And now, P infinite, which is 3 by 2 times PA naught, equals to 450. From these two, you can calculate PA naught and x. PA naught is 300, and by putting this thing here, you will get x as 100. PA naught is 300, x is 100. You can check these two equations and get these two values. Okay, now K equals to, on the next page, PA naught is 300 and x is 100. Now K equals to 1 upon T. T is 4.606. ln is converted into log, so 2.303 log. PA naught is 300, PA naught upon minus x. PA naught is 300 minus x is 100. But we are making one mistake here. We are making one mistake here because stoichiometric coefficient of A, because stoichiometric, listen carefully, because stoichiometric coefficient of A is 2, not 1. Because stoichiometric coefficient of A means reactant is 2, not 1. So we have to multiply that 2 here also. Just keep this thing in mind. Whatever order reaction, this thing keep in mind. Very, very important point. Important note. क्या मैंने ये बात लास्ट लेक्चर में बताई थी? स्टैक्योमेट्रिक ऑप्शन चेंज करेंगे तो क्या चेंज होगा? Have I told you in the last lecture? Anyone can confirm? If stoichiometric option is changed, then what effect it will have on the equations we derived? अरे स्टैक्योमेट्रिक ऑप्शन चेंज हो जाए तो क्या फर्क पड़ेगा, इक्वेशन जो अपन ड्राइव किया वो बताया था कि नहीं बताया था लास्ट लेक्चर में? someone is saying yes, someone is saying no. कोई जगे हुए लोग बता दो. Okay, I'm telling it again. Note it nicely. Let's say stoichiometric option is changed to m from 1. This is rate constant of reaction. And it is converting into product. Any nth order reaction. This is valid for any nth order reaction. Any nth order reaction. Nth order reaction. This is kind of shortcut you can keep in mind. What is the shortcut? In place of k, write mk. Write mk. Just in place of k, write mk. K is rate constant of reaction, except rate. Rate means ROR. If someone is saying just rate means ROR is k into concentration of A की power n. Here you don't have to do mk, just k. Irrespective of value of, this is irrespective of value of m. Whatever is the value of m, just write k here while writing rate. Rate means ROR. In short, मैं वापस बोल रहा हूं कि जहां जहां आपने डेरिवेशंस में के लिखे थे, जहां जहां जीरो में, फर्स्ट में, nth में, जहां जहां भी आपने के लिखा था उसकी जगह एम के कर दो. बस कहां नहीं करना है, कहां नहीं करना है, वाइल राइटिंग दी रेट ऑफ द रिएक्शन. रेट ऑफ द रिएक्शन में यहां रेट कांस्टेंट ऑफ रिएक्शन आएगा, क्योंकि इस रिएक्शन का रेट कांस्टेंट कितना है, के. तो अभी भी कितना आएगा, के ही आएगा. बाकी सब जगह पे मान लो फर्स्ट ऑर्डर रिएक्शन होता तो टी ऑफ, इफ इट इज first order reaction, then T of will be ln2 by K. Then in place of K, you will write Mk. Let's say it's zero order reaction. So amount reacted X is Kt. In place of K, you have to write Mk. Are you getting? Are you getting this thing? Just in place of K, write Mk, but you don't have to write while writing rate. Just rate लिखते टाइम आपको जस्ट K लिखना है. बाकी सब जगह पे जहां जहां आपने के लिखा है उसको क्या लिख लो, एम के. और एम के इज इक्वल्स टू किसके बराबर, एम के इज इक्वल्स टू के ओनली. या तो एम के लिख लो या फिर के लिख लो. एम के और के सेम ही है, ये याद करो. ये आपको बता रखा है, आई हैव टोल्ड यू अर्लियर एज वेल कि के इज रेट कांस्टेंट ऑफ रिएक्शन. this Ka is rate constant of A divided by इसका stoichiometric coefficient. So you can see from here K is equals to Mk. Keep this shortcut in mind. Just in place of K, write Mk. That's why I'm writing 2K, not K. So K will be equals to 1 by, this is 2, 1 by 4 times log 3 by 2. I have to put this 2, otherwise you will get wrong answer. And T half is ln2 by not K, 2K. ln2 by 2K. Why 2K? Because in place of K, Mk. What is the value of M here? 2. This is very, very, very important. Okay. Now going to the next thing. We were dealing with the pressure values. Now we will deal with if titration readings are given. If titration readings are given. While dealing with this type of questions, when titration readings are given, you know this from your earlier studies. कि titration are of three types. Which types? Acid base titration, redox titration, or precipitation titration. In general, here questions will be from acid base titration or redox titration. You have covered volumetric analysis or redox reactions or equivalent concept. You must have encountered there redox reactions like KMNO4 or hypo solutions or like that. And acid base reactions you must have covered in equilibrium, ionic equilibrium. So what is the important point here? Very, very important note. Volume of titrate. What is titrate? This is नीचे वाला and this thing is ऊपर वाला. What is ऊपर वाला and नीचे वाला? You know the titration. आप में से लैब में तो गए होंगे. You must have visited lab. So this thing is नीचे वाला. This thing is titrate. जो नीचे है जिसका टाइट्रेशन हो रहा है that is known as titrate. और जिससे टाइट्रेशन हो रहा है जो ऊपर से बूंद 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 गिरता है drop by drop, that thing is known as titrant. तो what I'm saying कि नीचे वाले की कॉन्सेंट्रेशन और ऊपर वाले का वॉल्यूम एक दूसरे के डायरेक्टली प्रोपोर्शनल होता है बाय यूजिंग इक्विवेलेंट कॉन्सेप्ट. I'm not going into that again because that is covered in the another chapter as well. Concentration of titrate will be directly proportional to volume of titrant. Concentration of titrate will be directly proportional to volume of titrate. Just keep this thing in mind. जिसका टाइट्रेशन हो रहा है उसकी कॉन्सेंट्रेशन और जिसके साथ टाइट्रेशन हो रहा है उसका वॉल्यूम एक दूसरे के डायरेक्टली प्रोपोर्शनल होंगे. टाइट्रेट की कॉन्सेंट्रेशन, टाइट्रेंट का वॉल्यूम. Titrate's concentration and volume of titrant will be directly proportional. Just keep this thing in mind and enjoy the answers. Just I'm giving you one example. Decomposition of H2O2. Decomposition of H2O2. Keep this thing in mind and remember it. This is first order reaction. You have to remember. Sometimes in NEET, it is directly asked which of the following are first order reactions. And it is mentioned in the NCERT as well. So after this lecture or the kinetics is over, then go through NCERT as well. First order reaction. Decomposition of H2O2 is first order reaction. It won't be given. You have to remember this. Now H2O2 का decomposition is H2O plus half O2. This is K. I have to find K. K equals to 1 upon T ln initial concentration of reactant and then H2O2 at time T. Now what will be given in the question? Time 0 T and volume of KMNO4 used. You remember KMNO4? KMNO4 is a strong oxidizing agent. KMNO4 is a strong oxidizing agent. This is which kind of titration? KMNO4 and H2O2 reacts, then redox reaction will take place. This will reduce and H2O2 will oxidize. Then this is redox titration. Redox titration and redox titration with किसके साथ? With H2O2. With H2O2. And you have given data V0 and VT. अभी ऊपर वाली चीज को देखो जिसका टाइट्रेशन हो रहा है. Who is titrate here? H2O2. जिसका टाइट्रेशन हो रहा है वो है H2O2. तो H2O2's concentration will be directly proportional to जिसके साथ टाइट्रेशन हो रहा है. मतलब किसके साथ हो रहा है? KMNO4 के साथ में. Titrant is KMNO4 and titrate is H2O2. Titrate is H2O2. Titrant is KMNO4. So KMnO4's volume and H2O2's concentration will be directly proportional to each other at each time. I'm saying it again. Concentration of H2O2 and volume of KMnO4 will be directly proportional to each other. लो question खत्म हो गया. That is the end of question. How? As we know कि concentration of titrate is directly proportional to volume of titrant. What is the volume used at T equals to 0? V naught. That is directly proportional to H2O2 naught, and H2O2 at given time T is directly proportional to Vt. Over and out. K equals to 1 upon T ln V naught by Vt. These datas are given. Enjoy the answer. K equals to 1 upon T ln V naught by Vt. How I'm writing this? Because of this important note. Within few seconds, you are getting the answer. This is one example of it. And just I'm asking one question. Give me answer as quick as you can. V naught or Vt में which one is bigger value? V naught and Vt, which one is bigger value? V naught and Vt, which one is bigger? Come on, come on. V naught, Vt में which one is bigger? बिल्कुल सही जवाब है. V naught is greater than Vt because it is reacting with H2O2 and H2O2 is reactant. H2O2 is reactant. So reactant's concentration is decreasing with time. H2O2's concentration is decreasing with time. So volume used to titrate it will also decrease. Volume used to titrate H2O2 will also decrease. H2O2's concentration is decreasing. That's why V naught will be greater than Vt. Second famous example from this section is hydrolysis of ester. Hydrolysis of ester. This is, remember this very vividly, pseudo first order reaction. This is pseudo first order reaction. Pseudo first order reaction. This is pseudo first order reaction. Do you know what is pseudo order? Have I taught you what is pseudo order reactions? Yes or no? Yes or no? Yes or no? What is pseudo order? Do you know? अरे हाँ ना बोल दो. I don't remember the last lecture. Have I told you what is pseudo order? If any substance is present in large amount or excess amount, then don't consider that substance and then give answer. Okay, Aryan is saying yes, then it means yes. CS3, COO, C2H5 plus H2O converting into, in presence of acid catalyst. This is acid catalyst. CS3COH plus C2H5OH. This is the hydrolysis of ester. This is ester. This is acid. And ये है जिसको पी के लोग शराबी बन जाते हैं, अल्कोहल. C2H5OH. So you have to find K of this reaction. Why pseudo? Because rate is independent of this acid catalyst concentration. So K will be equals to 1 upon T reactant. We won't consider H2O because H2O is solvent. Solvent is present in large or excess amount. So we won't consider this. So rate will be dependent on ester की concentration. तो this is ester naught upon ester at given time t. So which is equals to ln A upon A minus X. Now, what will be given? Given is time 0, t and infinite, and volume of NaOH used. V naught, Vt and V infinite. This example is important. V naught, Vt and V infinite. Now listen carefully. NaOH will do acid base titration or redox titration. Listen. NaOH will do redox और एसिड बेस रिएक्शन. NaOH को क्या पसंद है? एसिड और बेस? बेस. NaOH is strong base, so it will like acid. So acid base titration. What is the acid here? CH3COOH. So it is titrating CH3COOH. We are getting that. So can you comment ki V naught, Vt and V infinite, which one is the biggest? V naught or V infinite? Among V naught, Vt or V infinite, which one is the biggest value? Which one is the largest volume? Are V naught, Vt, V infinite. Which one is bigger? V naught or Vt or V infinite? अरे बोल दो, कुछ तो आंसर बोलो. Now confused. V naught, V infinite, दोनों आंसर्स आ रहे. This time NaOH is reacting with acid, not ester. So what is the proposition? Ki concentration of titrate. This is titrate now. CH3COH is titrate. This is acid. So titrate's concentration will be directly proportional to titrant's volume. So CH3COH concentration will be directly proportional to NaOH ka volume. That means these values are increasing because CH3COH will increase with time. So volume used to titrate will also increase with time because CH3COH is reactant, not reactant, product this time. CH3COH is product, so its concentration will increase. So volume used to titrate this will also increase. Now, I'm making one more column. Volume of NaOH used to titrate CH3COH. Sir, why are you making new column? It is already given now, V naught, Vt, V infinite. Because, look carefully, at t equals to 0, let's say this was A and this was 0. At given time t, this was A minus X, then CH3COH will be X, and t equals to infinite, ester's concentration will become 0 and this will become A. Now interesting thing, अच्छे से स्क्रीन पे देखो कुछ जादू हो रहा है. At t equals to 0, CH3COH concentration is 0. T equals to 0 पे कंटेनर में CH3COH is 0. But volume used to titrate it is something. Something means V naught, not 0. V naught is not 0. NaOH is still being used to titrate something in the container, but CH3COH is not there. Then NaOH will be titrating with some acid, but not CH3COH. Then with what? Acid catalyst. In container, CH3COH is also there and H plus is also there, but CH3COH at T equals to 0 is not present. Its concentration is 0. But acid catalyst means its concentration is constant throughout the reaction. Catalyst means its concentration is constant throughout the reaction. So volume used to titrate it will be also constant throughout the reaction. मैं वापस हिंदी में बोल रहा हूं, CH3COH तो कंटेनर में था नहीं, T इक्वल टू 0 पे, तो ये वॉल्यूम किसके लिए यूज हो रहा था? किसी के लिए तो होगा, कोई तो कोई एसिड होगा, तभी तो वॉल्यूम यूज हो रहा है NaOH का। तो किसके साथ यूज हो रहा है? H प्लस के साथ में, और मुझे पता है कि H प्लस इज कैटलिस्ट, सो इट्स कॉन्सेंट्रेशन इज कांस्टेंट। इसका कॉन्सेंट्रेशन कांस्टेंट है, तो थ्रू आउट द रिएक्शन जो इसके साथ वॉल्यूम NaOH का यूज होगा वो कांस्टेंट होगा। तो जो बचेगा, द रिमेनिंग वॉल्यूम after reacting with H plus will be used for CH3COH. NaOH is not titrating just CH3COH. NaOH is titrating CH3COH as well as acid catalyst, and its volume used to titrate H plus is constant throughout the reaction, which is equals to V naught. So remaining volume is used for titrating CH3COH. What is the remaining volume? Here remaining volume is 0 because whole V naught is used to titrate H plus. Then here Vt minus V naught, because V naught is going to titrate catalyst. Here V infinite minus V naught. This volume is available for CH3COH titration. Or we can say that this volume of NaOH is being used to titrate CH3COH. You can write this 0 as well as V naught minus V naught, because this volume, the constant volume V naught, V naught, V naught, this is used to titrate catalyst. Now this X is directly proportional to volume of NaOH used to titrate CH3COH. So this will be directly proportional to Vt or Vt minus V naught. Vt is total volume of NaOH. But for CH3COH, what volume is used? Vt minus V naught. The people do this kind of silly mistakes. They write just Vt, not Vt. Vt minus V naught. And A is directly proportional to, not V infinite. This is directly proportional to V infinite minus V naught. Now you can put this A and A minus X and you will get famous formula. This is very famous formula given in NCERT, but no derivation. So 1 upon T ln, this will become V naught, sorry, V infinite minus V naught upon V infinite minus Vt. You can remember this formula. It's very famous formula, but how it is being derived, you can see in front of your eyes. Then next, this thing was hydrolysis of ester, very good example of it. Third thing is, if optical rotation is given, optical rotation is given, you know from your organic chemistry's knowledge that the rotation means when plane polarizing light is passed through the optically active substances, then it will rotate the light. I think you must have studied this. This is 0. Here this side positive angles, here this side negative angles. If data is here, then inactive, otherwise optically active. Positive values, that means dextro, negative values means levo, D and L configurations. ये हुआ है कि नहीं हुआ है? Have you read or not? D and L configurations, PPL light, plane polarizing light. Okay, yes. Then that R, rotation, is directly proportional to concentration of the optically active substance. These are the angles ka values, positive angles or negative angles. If it is coming at 0, that means substance is okay. This has not been done in Chembur branch. Doesn't matter, just keep in mind ki that rotation ka value they will do soon enough. is directly proportional to the concentration of the substance through which light is being passed. C is concentration. And this R is not rate, this is optical rotation value. Optical rotation. What is optical rotation? Some angle. That means. So now we are studying here inversion of cane sugar. Very famous reaction, inversion of cane sugar. Inversion of cane sugar. This is also pseudo first order reaction. You have to remember these things. Pseudo first order reaction. You must have seen somewhere sucrose converting into glucose plus fructose. Sucrose converting into glucose plus fructose. Sucrose converting into glucose plus fructose. This is pseudo first order reaction. Or if I'm finding its K, then K equals to 1 upon T ln sucrose की initial concentration upon sucrose का at time T concentration. Now, if I write its full reaction, sucrose का formula you must be remembering C12H22O11. This is sucrose plus H2O. Then in presence of acid catalyst, glucose is C6H12O6 and fructose is also C6H12O6. Sir, why are you writing the same formula? Array, these are isomers and isomers have same chemical formulas. This is D configuration and this is L configuration. How to remember this? अरे you know glucon D, glucon D, glucon D. तो D से D मिलाओ, आंसर पाओ. C6H12O11. This is the same reaction. We will write in short form sucrose converting into glucose plus fructose. Okay. Then I'm doing some questions for this reaction. Sucrose converting into glucose plus fructose. K type 1 question. If rotation due to sucrose only is given. Rotation due to sucrose is given. What we need for the question? Sucrose. I know that sucrose concentration will be directly proportional to rotation due to sucrose. ये rotation but due to sucrose only, not due to all sucrose, glucose and fructose. This is R naught and this is RT. As I know कि R is directly proportional to concentration, so R naught will be directly proportional to S naught and RT will be directly proportional to ST. So K equals to 1 upon T ln S naught upon ST. In place of that, I am writing K equals to 1 upon T ln R naught upon RT. Same as decomposition of H2O2, just R naught in place of V naught and RT in place of VT. Similar formula. You don't have to remember two formulas. Just in place of V naught, here it is R naught, and in place of VT, here it is RT. And second, if rotation due to all means solution means sucrose, glucose and fructose, ये given is given. Here it was due to sucrose only, here it is due to all means sucrose, glucose, fructose means solution. So time 0t infinite and rotation is due to solution R naught, RT and R infinite. Here we get formula. I'm writing directly because derivation is kind of big. So 1 upon T ln directly, it is similar to hydrolysis of ester wala formula. Just in place of V, put R. Same formula. It's easy to remember. R naught, sorry, R infinite minus R naught and R infinite minus RT. Just same formula as hydrolysis of ester. सेम एज, ये सेम नहीं लिखना चाहिए, सिमिलर, माइनस आर नॉट, सिमिलर टू hydrolysis of ester, and this is similar to decomposition of H2O2, similar to decomposition of H2O2. You don't have to remember 4 formulas, you just have to remember 2 formulas, and then you can get the answer. Okay, this whole big section was about rate constant, finding rate constant of first order reaction using different information. We have used 3 kinds of information: pressure related information, titration readings, and then optical rotation. Last topic in kinetics is about Arrhenius collision theory. That means effect of temperature on rate constant. Let's, we are studying this topic in detail. See, here it is A and B. I'm treating A as one type of molecule, B as 2 type of molecules, and so there will be 3 type of collisions in this container. A ka too many molecules, B ka bhi many molecules are here. So there will be 3 kind of collisions between, in this container, between A and A, between B and B, and between A and B molecules. And let's say this reaction is happening, A plus B converting into AB. So for this reaction to take place, we have to consider what is this means: Z11, Z12, and Z22. Z11 means collision between A and A per unit volume per unit time. Z12 means collision, total number of collisions between A and B per unit time per unit volume. Z22, total number of collisions between B and B molecules per unit time and per unit volume. So for this reaction, we will be considering only Z12. Z12. Do one thing, take PDF of this, because I have to delete this. 15 pages are the maximum limit of this thing. Interested students can scan it and get PDF. वन सेकेंड पहले ये QR कोड को स्कैन कर लो. Okay, done. This is the last page. Okay. Now listen carefully. This is theoretical thing, so you have to listen. They are proposing that if we find rate of this reaction, rate means how many AB are producing, using this Z12, like कि the number of molecules of A and B are colliding, if that many numbers of AB are producing, number of collisions between A and B are happening, they are assuming if every collision result into the formation of AB, then that rate will be theoretical rate. It is too simplistic to say that every collision between A and B will result into the product formation. In real life, in actual, this is not happening. In reality, the actual number of AB will be much lesser than Z12. Means theoretical rate that is calculated from directly from Z12 and the actual rate, the difference is too stark, or difference is much bigger difference. Theoretical rate is found to be much bigger than the experimental rate or actual rate. That means every collision between A and B is not resulting into the product formation. You can relate this thing. You can relate, just I'm giving you the hints, not saying too many words. You can relate this thing or this theory to bio का one chapter. Geology में there is one chapter, reproduction. Now relate this thing कि every collision between A and B won't result into the product formation. The collision that actually produces product is known as effective collision. The collision that actually produces a product is known as effective collision. And for a collision to be effective collision, two barriers must be overcome. Every collision won't result into the product formation. The collision that actually produces a product is effective collision, काम का collision. And for a collision to be effective collision, two barriers must be overcome. What are those barriers? Two barriers are energy barrier and orientation barrier. For a collision to be effective collision, some energy must be, some threshold or some activation energy must be possessed by the reactant molecules. Not every collision just they are touching each other and we are counting AB will be formed. No, AB won't be formed. There is kind of threshold energy that minimum amount of energy must be possessed by A and B. If they have that kind of energy and then they are colliding, then that collision will be effective collision. Let's say they have that kind of energy, required energy, still they are colliding in the wrong direction, wrong orientation, then also no product. Orientation also very important. If you have energy but still colliding in the wrong direction, then no product. So two barriers must be overcome, energy barrier and orientation barrier. Two means two, not one and two. एक चला लिया काम नहीं चलेगा. You have to take care of both the factors, energy factor as well as orientation factor. Proper orientation with required amount of energy, then that collision will result into the effective collision. This is the theoretical part of this Arrhenius collision theory. Now, doing some maths and derivation. First one is energy barrier. Here, I'm drawing two graphs. While comparing elementary and complex reaction, we have drawn some graphs. Remember those graphs? This is potential energy and this is progress of reaction. If I'm making graph like this, can you tell me this graph is for endothermic or exothermic? Come on. This is for endo or exo? I have taught you this. Remember 4 weeks ago, this is for endo or exo? अरे बोल दो, this is for endo or exo? This is reactant, this is product. If energy of product is greater than reactant, then this reaction is endothermic reaction. बिल्कुल सही. Yajat dot. Very good. सही. Okay. Now this value, this much value is known as activation energy. Activation energy. They represented by EA. And this total value from this peak to this much energy, this energy is known as threshold energy. Threshold energy. This much energy is activation energy, and from this x-axis to the peak, this energy is represented by the threshold energy. The difference between these two must be cleared by the graph drawn here. Activation energy and threshold energy means activation energy is lesser than threshold energy. Threshold energy is total energy of the reactant molecules to cross the energy barrier. And this activation energy is extra kinetic energy or additional kinetic energy possessed by the reactant molecules over and above this average energy of the molecules. This much of energy is already possessed by the molecules. What extra kinetic energy is required to cross the energy barrier? And these all two values are minimum values. मिनिमम टोटल एनर्जी इसके ब्रैकेट में लिखता हूं, मिनिमम टोटल एनर्जी. And in bracket of this, minimum additional kinetic energy than what they already have. Just understand this from the simple example, like your JE ka cutoff. How many of are appearing from JE? For JE, raise your hand. For JE. raise your hand. JE वाले हाथ खड़ा करें. JE. नीट वाले हाथ खड़ा करें. नीट appearing for नीट. ओके. बाकी वाले किसके लिए अपीयर कर रहे हैं? कोई और एग्जाम है क्या कोई? ओके. नीट वाले अपने पॉइंट ऑफ व्यू से, अच्छा क्यूट के लिए भी अपीयर कर रहे हैं क्या? ओके. सीईटी. ओके, ठीक है. Just understand from the point of view, JE point of view, you will get the example. Let's say for JE, if someone gets 150 marks out of 300, then he will get decent college. Let's say, assuming कि cutoff marks are 150 marks. We are assuming cutoff marks for JE as 150 marks. So total 150 marks, minimum how many marks required to cross the JE barrier are 150 marks. So 150 marks are like threshold values. Total how many marks are required to cross the JE barrier? But let's say you people are getting 100 marks on average. On average, you people are getting 100 marks right now. On average, someone must be getting more than 150, someone will be getting less than 150. I'm just assuming ki, let's say average value you are getting right now is 100 marks. So how many extra marks you need to cross that cutoff? The 50 marks. How many extra marks you need to cross that cutoff? 50. That 50 represent by activation. That 50 is more important because 100 you already are getting. How much extra you want? 50 marks to cross that. How many extra, minimum extra marks you need to cross the JE barrier is 50 marks. That is the difference between threshold and activation. Activation is 50 and threshold is 150. Okay. That is separate issue. Let me complete kinetics first, and sometimes you will be given some gyan also. Okay. So this is the difference between activation and threshold energy. I'm writing something. The fraction of molecules, fraction of molecules having that extra kinetic energy, additional kinetic energy is greater than equals to EA. Fraction of molecules having that extra kinetic energy is greater than equals to EA are, I'm writing it directly from Maxwell's distribution curve. Maxwell's distribution curve. This must be taught by physics ka heat and thermo, I think so. HNT in physics. E raised to power minus EA by RT. E raised to power minus EA by RT. You have to remember this thing correctly. What does this E raised to power minus EA by RT represents? E raised to power minus EA. EA is active energy, R is universal gas constant, T is temperature. This represents how many fraction of molecules have energy greater than equals to EA. Means these molecules are available for the effective collision. These many molecules are good molecules. Good molecules means point of view the effective collision. So now orientation factor. Orientation factor. I'm giving you one example. Let's say two NO2 is converting into N2O4. One orientation is this orientation and another one is this is one, this is two. Can you tell me which one is proper orientation for this reaction? Can you tell me just common sense? Which one is proper orientation for this reaction? By which orientation this reaction will take place? By one or by two? It's common sense. Use your common sense. This orientation is proper orientation. This is not proper orientation. Here, steric hindrance will be there. Steric hindrance will be there. Steric hindrance will be there. So by this orientation, even if they have energy, required energy, EA energy greater than equals to EA, then also this reaction won't happen due to improper orientation. This is proper and this is improper. Okay. Then probability of proper orientation. Probability of proper orientation is, let's say, P. Probability of proper orientation is P. Probability of proper orientation is P. Now think again. We have considered two factors, energy factor, orientation factor. I'm giving you just simple example. Let's say 1,000 collisions between A and B were happening. 1,000 collisions were happening. If 50% of molecules have required energy, means energy greater than equals to E raised to power minus EA by RT. And let's say probability of proper orientation is half. Probability of proper orientation is half. Then how many AB are forming? I have said total collisions 1000. 50% molecules have required energy and 1 by 2 is the probability of proper orientation. Then how many AB molecules are forming? Come on. Simple है. 1000 का 50% is 500 and then 500 into half and 250 molecules of AB are forming. That means 250 collisions of between A and B are effective collisions. Theoretical rate 1000 but actual rate 250. Theoretical 1000 but actual 250. So we can say this K equals to Z into e raised to power minus EA by RT into P. This is collision factor of frequency, whatever you can say. This is energy factor, means fraction of molecules have required energy, and this is probability via orientation factor. And K is taken as A into e raised to power minus EA by RT. This constant value is combined and taken as A. And no guess for A's name. A is for Arrhenius constant. This is given by Arrhenius, so Arrhenius constant. Arrhenius constant, and also known as frequency factor. K is rate constant is equals to A into e raised to power minus EA by RT. Now some things for this reaction equation. This is known as Arrhenius equation. This is known as Arrhenius equation. Some few extra points on this. Say K equals to A into e raised to power minus EA by RT. What will be K max? K max value. What can be K max? This value can be maximum as 1. E raised to power minus EA by RT can be maximum of 1. Okay. So K max is equals to A. K max is equals to A. A into 1 means this value is getting equals to 1. Fraction of molecules having energy E greater than equals to EA. That means we are assuming that all the molecules are having energy greater than equals to EA. E raised to power minus EA by RT represents fraction. Fraction maximum कितना हो सकता है? 1 हो सकता है. Fraction maximum कितना हो सकता है? 1 हो सकता है. In two ways it can happen to be 1 if EA equals to 0 or if T tends to infinite. EA 0, then e की power 0, e की power 0 is 1. T infinite, something upon infinite is 0 and e की power 0 is 1. Now feel it, if cutoff is reduced to 0, let's say some magical things are happening in your exam and cutoff is 0. So all the people who are appearing will cross the barrier, assuming that no one is getting negative marks. And if temperature is increased to infinite, that means their energy is much bigger than the required energy. That means all the molecules are crossing that energy barrier. This is K max. K max can be equals to 1 and this can get max by 2 ways. Second, K equals to A into e raised to minus EA by RT. Its graph is like, this is like similar to e raised to minus KT. You remember first order that T was time, this T is temperature. So this is K and this is 1 upon T. And this will be similar to exponentially decreasing. This is not T, this is 1 upon T. By looking at this graph, I can conclude that as T increases, temperature increases, then K increases, rate constant increases, irrespective of endothermic, exothermic, irrespective of forward or backward. As temperature increases, K increases, because you can feel it. As temperature will increase, then e to the power minus EA by RT will increase. How? If I increase the temperature, then 1 by T will decrease. If 1 by T is decreasing, then this graph is getting higher and higher. And second, as EA increases, then K will decrease, irrespective of type of reaction, forward, backward, endo, exo. Now you can feel it. If cutoff marks are increased, then more people will cross the barrier or less people will cross the barrier. Less people, less means K is decreasing. Temperature is increased, then K is increased. If EA is increased, then K will be decreased. And third point, A and EA are temperature independent. A and EA are temperature independent. Okay. We will be taking 10 minutes extra so that we can complete. Okay. Interested people can stay 10 more minutes. This is not compulsory. This whole exercise is not compulsory. If you want, then you can stay for 10 more minutes. Okay. If it's okay with you. अरे चलेगा, पढ़ लोगे 10 मिनट और कि रोने लग गए? भूख लगी है? अरे तुम बोलो तो पढ़ाओ, नहीं तो छोड़ दूं. How many are in favor of 10 more minutes? But this is last lecture of kinetics. And for 2 to 3 weeks, I am on leave. So this is my last lecture as well. Okay. It's optional. If you want to stay, then you can stay. Otherwise, you can leave the meeting. है ना? Fourth point, K equals to A into e raised to power minus EA by RT. If I do ln on both sides, let's play ln. Ln K equals to ln A minus EA by RT. I can draw graphs also. Ln K versus 1 upon T. You can see this is y equals to mx plus c. This is y equals to mx plus c. Many questions are asked directly using this equation. In boards also this can be asked. And from graph point of view as well as this equation point of view. This is y equals to mx plus c. Question will be given like ln K equals to, let's say, 0.69 minus, let's say, 500 by T. And you will be asked value of Arrhenius constant and value of activation energy. Just compare these two. You know 0.69 is ln2. Okay. This kind of graph you will get. This is ln A, and slope of this graph you can see from here. This is slope. This is 1 by T. This graph is with 1 by T. Slope is minus EA by R. Now, if I convert ln into log, then log K, there will be 2.303 factor. I'm dividing the equation by 2.303 while converting ln into log. So log A minus EA upon 2.303 R into 1 upon T. This is log K versus 1 upon T reaction. You have to be aware that it is given between log K and 1 by T or ln K versus 1 by T, because slope will be different. Here slope is EA upon 2.303 minus. So here graph will be log K versus 1 upon T minus EA upon 2.303. Okay. Examiner will get you confused between these two equations. Don't be get confused. Here EA upon R, here EA upon 2.303 R. ln K log K. Then one more thing. ln K1 equals to ln A minus EA upon RT1. This is at T1. Why I'm not changing A and EA? Because A and EA are temperature independent. ln K2 equals to ln A minus EA upon RT2. This is at T2. If I subtract 2 minus 1, then I will get, see, ln K2 minus ln K1. ln K2 minus ln K1 is direct ln K2 by K1. ln K2 minus ln K1 is ln K2 by K1. ln A will be cancelled out. See what I'm getting, ln K2 by K1 equals to EA by R 1 upon T1 minus 1 upon T2. 1 upon T1 minus 1 upon T2. This equation is used in various type of questions, temperature change questions. This can be directly used. Okay, this equation is very useful. Okay, then next thing, 6 is effect of catalyst. Let's say this is reaction A reversibly converting into B, and if delta H is less than 0, that means exothermic. I'm drawing graph for exothermic. In last graph we have taken endothermic, so for fun we are taking exothermic now. This is potential energy, this is progress of reaction. See here, this times this is A and this is B. Now what will happen due to catalyst? What will be the effect of catalyst? This is EA, but EA which one? Forward. This is EA forward, and this one is EA backward. EA backward. What will happen due to catalyst? Due to catalyst, this peak will be reduced. Let's say your exams cutoff is decreased somewhat. Some magical powers and your exams cutoff is decreased, let's say by X amount. So this is, ऊपर वाला graph is due to without catalyst. Examiner will say कि reaction is taking alternate path when catalyst is used. Alternate path, the convenient path. Obviously, Here, without catalyst, the peak height is more. And with catalyst, the peak is reduced. So reaction will take alternate path, different path to reach, to form the product. And this is with catalyst. So due to catalyst, what happens is the peak height is decreasing. Now, what will be the effect on EA forward and EA backward? See, both EA forward and EA backward are now reduced by the same amount, X amount. This amount is X, and EA forward and EA backward both are getting reduced by this amount. This is EA backward, let's say dash, and this is equals to EA forward and minus X. And here, let's say this amount is equals to EA backward dash, and this is equals to EA backward minus X. And this difference is equals to delta H. You can see due to catalyst, there is no change in delta H. This is still the same with or without catalyst. It is still delta H value only. There is no change. So if I write the effect of catalyst, first one, activation energy for both forward and backward decreases by same amount. What is that amount? X. Active energy of forward direction, active energy of backward direction, both decreases by same amount, X. As both are decreased by same amount, so there is no effect on, या no change in क्या है जरा बताओ, delta H. No change in delta H. These are asked directly, no change in delta H. Now, as we know, कि cutoff is decreased, so more molecules will convert into product. That means rate constant will increase, but the rate constant of forward reaction and rate constant of backward reaction will increase by same extent, because active energy of forward and backward reactions are decreased by the same extent. Listen carefully. Rate constant will increase because active energy is decreasing, but rate constant of forward direction and rate constant of backward direction both will increase by same amount or same extent, because respective active energy was decreasing by same extent. Now, rate constant, या both rate constant लिख लेता हूं. Both means forward and backward. Both rate constants will increase by e की power x by rt. This factor is very important. E raised to power x by rt, that will increase by this factor, as both k forward and k backward increase by same extent, same amount. So there is no change in k equilibrium. Four factors: active energy, forward backward both decrease by same amount x. There is no change in delta H. K forward and k backward both increase by same factor, which is e की power x by rt, and as k forward and k backward increase in same amount or same extent, that's why no change in k equilibrium. These are the four effects of catalyst. Catalyst means we are taking positive catalyst only. And one last thing, there is one term, temperature coefficient. This is known as mu. Okay, and mu is just kt plus 10 upon kt. If we increase temperature by 10 units, that ratio is known as mu. And if you have to find kt dash upon kt, that is equals to mu raised to power t dash minus t upon 10. You can use this formula directly. and this mu is generally between 2 and 3. If nothing is mentioned, then this 2 is by default. By default, if nothing is mentioned, then you can take mu as 2. One example, if mu is equals to 3, then find K 70 degree upon K 20 degree. See, it's very easy. 3 raised to power 70 minus 20, 50 upon 10. 3 raised to power 5. Some extra examples of first order kinetics. पहला, बैक्टीरिया मल्टीप्लिकेशन, जो दूध में बैक्टीरिया बनते हैं, दूध से दही बनता है, दैट बैक्टीरिया मल्टीप्लिकेशन is first order kinetics. And second, radioactive disintegration. Physics, in modern physics you will be covering this radioactive disintegration. This follows first order kinetics. And third and last, thickness of oxide layer. Thickness of oxide layer. This is also first order kinetics. Just remember these things. Sometimes it is asked directly. Okay. Over and out. Tata, bye bye. Enjoy. Have a nice evening and night. Your kinetics is over. PDF.